Okay, next up, we have Danika. Danika is a rising 8th grader at the Harker Middle School in San Jose, California. Go ahead, take it away, Danika.
Hi, my name is Danika, and I'm a rising 8th grader at the Harker Middle School. Today, I will be sharing my project about Alzheimer's. Alzheimer's is a progressive disease, which means it gets worse over time. It causes the connections between brain cells to degenerate and die, due to which different sections of the brain cannot properly communicate with each other, which makes it harder for the patients to carry out their daily activities. If doctors can identify Alzheimer's earlier, they can start treatment sooner and help the patient. As Alzheimer's affects many elderly people and is both one of the top 10 causes of death and currently incurable, we need to detect it early. The question is, can we improve prediction accuracy perhaps by using multimodal data? In previous work, Jack Albright has shown that you can use AI to predict Alzheimer's effectively. However, Jack only used one modality to build his prediction AI. We build upon and improve on his results by using additional modalities. Because the AI relies on data and more data usually leads to better performing AIs, my hypothesis is that if I use multiple different modalities, my AI will be able to predict Alzheimer's better than just single modality data. Multiple modalities means more types of data, such as clinician notes, MRIs, images, and measurements of the brain. I decided to use the OASIS 3 dataset, which studied over 1,000 patients for 30 years. Because they studied patients over time and some patients developed Alzheimer's during that time and some patients didn't, I wanted to see if we could predict early which ones would get Alzheimer's and which ones wouldn't. The OASIS dataset is a very big and has many modalities in the dataset. I decided to use ADRC, MRI, and FreeSurfer. ADRC are clinicians' evaluations of patients based on many observed symptoms and tests. The MRIs are the MRI scan images. FreeSurfer is measurements and volumetrics of the brain. They are created by the app called FreeSurfer, which uses 3D scans of the brain and outputs measurements. Each modality has a corresponding prediction for clinical dementia rating, or CDR. 0 means no Alzheimer's, and the rest of the scores, 0.5 to 3, show different severity levels. The higher the score of your CDR, the worse the Alzheimer's you have. The original dataset had 5 categories, or 5CAT for short. The treatment for Alzheimer's is similar for all non-zero CDRs. Therefore, to maximize the capability of my AI, I decided to explore the impact of combining categories. Therefore, from 5 categories to 4 categories to 3, and finally down to just 2 categories, Alzheimer's or no Alzheimer's. In the table shown on the screen, I showed which categories I combined to reduce the number of categories. I also reduced the number of normal data points so that the AI had about the same number of normal patients and Alzheimer's patients to learn from, which addressed the data skew. Then I used AI to predict Alzheimer's from each modality by itself and used some ways to combine the modalities. For combining the modalities to come up with a final prediction, I used several different methods. 1, aggressive, meaning that if any of the modalities predict positive, the final prediction automatically predicts positive. 2, conservative, meaning that if any of the modalities predict negative, the combined prediction is all automatically negative. Voting, meaning that we go by whatever the majority of the modalities say. And conditional, meaning that the ADRC overrides the decision, but the only case is if the ADRC predicts no Alzheimer's, but both FreeSurfer and MRI predict yes Alzheimer's, then that is the only case where MRI and FreeSurfer would override ADRC, and the final prediction would be yes. The metrics used were the standard machine learning metrics of false positive rate, false negative rate, accuracy, AUC, and RLC. False positive means that the AI predicted Alzheimer's, but the patient did not eventually get sick. False negative means that the AI said the patient would be healthy, but in fact, they went on to get Alzheimer's. AUC and RLC showed the trade-off between false positives and false negatives. In my case, since we wanted to treat patients early, the worst thing is a false negative, since then a patient would not get treatment, but would become sick. I also checked confusion matrix for any anomalies to make sure that the AI could predict all the categories well. For the results of the ADRC modality, random forest with 2cat worked best at 45 trees, with an accuracy of 92.4%. For free surfer, K nearest neighbor worked best, again with 2cat, where K was 17, with an accuracy of 69.2%. For MRI, again with 2cat, the residual neural network worked best with 200 layers and a learning rate of 0.001, with an accuracy of 81.3%. As you can see, ADRC performed best with an AUC of 0.98, which makes sense as it is the clinician's diagnosis based on the patient's symptoms, which already takes multiple inputs into account. The key question is, can we do better than just ADRC by itself? The answer is yes. As you can see here, the conditional combination, the last column, worked best for predicting Alzheimer's with a dramatic 50% improvement when it came to forecasting Alzheimer's, while doing reasonably well on other metrics. It was the best compromise and it already did work very well. Next, for my project, I will just share my So this is my app, and right now it only works for MRIs, but essentially what happens is that I can go with the check button and I can pick an MRI image. Let's just say I picked this one. It'll check it and it will talk to the AI, and the AI predicted that the risk of this patient getting Alzheimer's is high. Next, if we go again, let's show this one. The risk is low. So yeah. That was my app. My hypothesis was supported and the multimodal data worked better than single modal data. I also saw firsthand that data skew could cause bias, and working with multimodal data was tricky. I also learned how to connect an image AI to an iPhone app. For the combining modalities methods, I thought that the voting method would work best, but I was wrong. The conditional method ended up working best because the ADRC modality did really well. For future work, I do want to add more modalities and try new combinations to further test my hypothesis that more modality leads to better predictions. Currently, my iPhone app only supports the image modality, and I want to enhance it to also support multiple modalities like the rest of my project. Thank you so much for listening to my presentation. I appreciate it, and I hope you learned more about Alzheimer's, AI, and data. Thank you.
Thank you very much, Danika. We'll wait for a minute and see if anybody has any questions, and then we'll move on to the next presentation. So one question I have is, how much of memory did all this data consume? Do you need to have a lot of space in order to have, because it's 3 modalities. So in terms of space, did you have any issues?
I don't think so, but I do get that space can be an issue since this has multiple modalities, which is a lot of data, but I don't.
Okay, so it was not an issue for your project. Okay, got it. Thank you very much, Danika.